Today we are going to study about energy stored in a capacitor. So, the work done by an external agent to charge the capacitor is stored as its energy. That is, the work done by an external agent to charge the capacitor is stored as its energy. That is, potential energy is equal to the work done. So we can write W is equal to integral dW. So what is the limit? The limit is from 0 to Q. That is, we are charging the capacitor from 0 to a charge Q. So the minimum charge or the initial charge was 0. That is, there were no charge initially, and we are charging the capacitor to a charge Q. So we know that V is equal to dW by dQ, and we can write dW is equal to V dQ when we are substituting here integral 0 to Q V dQ. So we have Q is equal to CV for a capacitor. That is, Q is the charge, C is the capacitance, V is the potential across the capacitor. So we can replace V by Q by C. That is, we can substitute V here, integral 0 to Q by C into dQ. So we can take C outside and integral 0 to Q dQ. The answer will be Q square divided by 2C. So the energy stored in a capacitor is Q squared by 2C. So this is one answer, and we can substitute Q is equal to CV. So we can substitute the value of Q here. So U is equal to Q squared by 2C, and Q square is equal to C square V square divided by 2C. We can cancel C and C. So the answer will be C V square divided by 2. So the final expression U is equal to half C V square. So this is the second expression, and we can substitute for we have Q is equal to CV, and we can substitute for C is equal to Q by V. So U is equal to half Q by V into V square. So it will be half QV. So U is equal to half QV. U is equal to half QV. So these are the three expressions for energy stored in a capacitor. So I'm going to write it here. U is equal to half CV square, half QV, and Q square by 2C. Q square divided by 2C, or half Q square by C. So energy stored in a this is the energy stored in a capacitor. So next topic is energy density of a capacitor. So energy stored per unit volume of a capacitor is called energy density. That is, energy density is the energy stored per unit volume. U is equal to energy stored per unit volume. So for a parallel plate capacitor, we can write volume is equal to A into D, where A is the area of plate or area of cross section of the plate, and D is the distance between two plates. A is the area of plate and D is the distance between two plates. So the volume will be A into D, and we have energy stored is equal to half CV square and volume as A into D. We have for parallel plate capacitor C is equal to epsilon 0 A divided by D. So we can substitute the value of C here. So the answer will be half CV square. So epsilon 0 A divided by D into V square divided by area into distance. So we can cancel area, that's it. And so we can write it as half epsilon 0 V square divided by D square. We know that E is equal to V square by D square. Electric field is equal to V square by D square. So we can substitute it here. U is equal to half epsilon 0 E square. So the energy density of a capacitor, the energy density of a capacitor, energy density of a capacitor U is equal to half epsilon 0 E square.